Alright guys, sorry I didn't realize that last video had gotten so long. So here is, I'm going to say, part 2 of proving why a carry look-ahead adder is so much faster than a ripple adder. So here we've got the same two equations. I'm going to add a little subscript here. And so this is just saying that the sum of, let's say, whatever carry we're on equals the x of that like the sum of whichever bit we're on equals the x input of that bit XORed, and this is the symbol for XORed with the y input for that bit XORed with the carry for the previous bit, so that I minus 1. And then here is the carry for the next bit equals the x and the y, or the y and the carry in, or the x and the carry in. So these were the equations that were in the last video, and they are it's kind of standard to build a full adder, but you can do something to this carry to make it a little faster. So we're going to say carry of the next bit equals the x input of this bit added to the y input, and now we're going to pull the carry in out because it's the same. And then we're going to say the x input ORed with the y input. Okay, so we just kind of used factoring to bring that c out. And so now we're going to do a little substitution. So we're going to say this term equals gi, and we're going to say this term equals, that's a horrible p, pi. So over here we've got gi equals xi anded with yi, and pi equals x ORed with yi. Alright, so if you remember back in my other video, we had two lines, and one of them was ORing the two inputs and the other one was ANDing the two inputs. So this is where those two gates came from. So I was making pi and gi. Okay, so now we're going to substitute down here, and we're going to say, so this was kind of all theoretical. Okay, now we're going to go into the physical. We're going to say for the first carry. Okay, so if we were adding the two numbers from the last, actually, whatever. This is a different two numbers. So we're going to say this is whatever in this box is the 0 carry. Whatever in this box is the first carry, the second carry, the third carry, and the fourth carry. So those are all the carries. So we're going to say for ci, because c0 is just whatever you get at the input. It doesn't matter. Okay, but for the first carry and the second and the third, and I know you can't see that, but that's okay. Alright, so for the first carry, we're going to say c is 1, and then we're going to say gi, because we're going to substitute this. So we're going to say, imagine that this was 1, okay? Then we're going to substitute in, and we're going to say gi, actually this should be I plus 1. So now we're just going to make these substitutions. So we're going to say ci plus 1 equals gi plus, oops, and there should be an I up here, ci pi. Actually, I'm going to switch these around. Whoops. That would be helpful if I was drawing with a brush. pi ci. Okay, so now we're going to plug in some numbers. Sorry, I guess here's the real part. So if this was c1, this is going to be g0, because I plus 1 is 1, so that would mean this would need to be I minus 1 if this was I. So g0 plus p0 c0. Done. Piece of cake. No problem. That's not a 0. C0. Okay. So now we're going to go I'm going to run out of room here. C2 equals, so C2 is, we're going to go back up here, we're going to say C2 is going to equal G1. Actually, I'm going to pause this video and rewrite this equation real quick. Okay, so the only thing I did here was saying instead of I plus 1 equals I, we're going to say I equals I minus 1, I minus 1, I minus 1. Alright, so that's a little easier. Okay, so now that C is 2, so I is 2, G 2 minus 1 plus P I minus 1, so 2 minus 1 is 1. And now we're going to do the carry I minus 1. Well, the carry I minus 1 is going to be the carry of 1. Well, what is the carry of 1? The carry of 1 we just found in the previous step is this. So we're going to substitute this in for the carry of 1. Alright, and so we're going to say G0 plus P1 P0 C0. So what we were doing there is we were saying we were taking this and we were going to multiply it by P1. So you had to expand it through, or factor it, expand it through. So P1 times G0 is this term, and then P1 times P0 C0 is this term. Alright? And then we're going to say C3, and hopefully you guys should be getting the pattern now. So G2 plus P, going back up here, so if we're on C3, this is going to be P2 times C minus 1. Well, so remember, we just found C minus 1 in the last one, so we're going to put what is in here, we're going to multiply that by P2. So we're going to say P2 G1 plus P2 P1 G0 plus P2 P1 P0 C0. Done. Alright, so they're getting longer and longer. So I'm going to pause the video real quick so I can move these inputs. Okay, and now we have room for C4. C4. No joke. It's explosive math here. Never mind, that was kind of stupid. Alright, so again, going back to the pattern, we get G3. That's not a 3. Boy, I tell you, I'm having problems with 3. Alright, G3 plus P3 times all of this stuff. So that's going to be P3 G2 plus P3, dang it, oh, that's a bad P2, whoops, yeah, G1, that's a cool looking G, it's like retro, P3, P2, P1, G0 plus P3, P2, P1, P0, C0. Done. Okay, so now we've got these really cool 4 equations, and these are the carries. So if you remember in my previous video, I had those muxers. So those muxers were calculating each of these things. So that would be one, and then here would be another mux line, and here would be another mux line, and so each of these was its own mux line. So that's how I got the carry. So then after the mux line, I ORed each of the lines together and got the carry. So now if you look at this, remember in the the part 1 of this video, we had the schematics, and we counted like the 1 and the 2 for this one, and then the 3 and the 4 for this one, and then the 5 and the 6 for this one, and so those were the delays, okay? And so now let's count the delays in here. So to calculate this carry, we've got an AND gate here, and then we OR it together. Okay, so that is, whoops, brush would help. That's 2 time delay. Okay, now if we look at this one, we have AND gates, and then we OR them all together. So that would look like, actually I'm going to draw this first one first. So 2 AND gates, and you OR the AND gates together, and then you have your inputs here, and so this is 1, 2. So that's where this 2 comes from. And then we go for this one, and you've got, actually I guess that one doesn't really matter. I am going to delete that. Sorry. This G isn't really AND with anything, it's just inputted. Whoops. It's just inputted right there. And then this is ORed together. And here are these inputs, and here are those inputs. Okay, and so we've got 1, 2. So this one is also 2 delay. Actually, I'm going to change colors real quick. I feel like Sal from Khan Academy. I've never done writing on Notepad before, or on Paint before. It's kind of weird. I'm really bad, as you guys can see. Okay, and now if you notice, this one is going to have 1, 2, 3 AND gates, and they're all going to be ORed together. And again, that is only 2 cost delay. And then this one is going to have 4 AND gates, and then that one, and they're all going to be ORed together. And again, this has 2 delay. So if you notice, this only has 2 delay. So that's really, really nice. So now we can figure out all the carries in 2 time delay. So we're going to say to find the carries, it takes 2 time delay. And to find these P's and these G's was another gate, right? So we had to AND these and we had to OR these. So to find everything in here, to find the P's and the G's, was 1 time delay. Okay, so there's 1 time delay for the P's and the G's, and now we can use the P's and the G's in here to calculate the C's, and each C gave us only 2 time delay. Okay, so now we need to figure out how much the sum is going to give us. And if you remember back, the sum was 2 XOR gates. Boy, those are horrible. Bam, 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 and that's 1 and 2. So the sum is also 2 time delay. So now we're going to add all of these together, and we're going to get a total of 5 time delay. So if you remember from the ripple adder, it had a total of 8. I'm going to write down here 8 time delay for the ripple. And now we just noticed that for the carry look ahead adder, carry look ahead, it only has 5. So comparing these two, you obviously, if you have a brain, can see that the 5 is much better than the 8. Actually, it's not much better. It's slightly better. Now, when you chain the ripple adders together, these ones just add incrementally. So you'd get like 16, and then 24, and then 32, and so on. So when you chain the carry look ahead adders together, it doesn't add. It actually adds 2 each time. So, whoops. So then this would be 7, and this would be 9, and this would be 11. Again, look at this 3. It's horrible. Okay, so now you've gotten 4 levels deep, and now instead of comparing 5 to 8, you're comparing 11 to 32. That's a pretty big difference. I'm going to leave it here for this video because I am just about out of time. But as you can see, the potentials of this adder are great, and I might actually add a part 3 onto this tutorial to show you why this is only increasing by 2 every time, and this is increasing Actually, you should understand why this is increasing by itself. But okay, I've got like 5 seconds left, so gotta go. See ya. Thanks for watching my video. Bye.